So, Madhumita ma'am, are you available here?
Yes, sir.
Okay, ma'am. So I request to start the session, ma'am.
Good evening, everyone. I, Madhumita Gupta, welcomes you all on behalf of IAC, IIT, and Applied Science Department of Sage University Indore to the fourth day of this enriching faculty development program. Yesterday, we witnessed around 140 faculty members, and there were valuable insights and discussions. And today, it will be more engaging interactions. Uh, as our keynote speaker is Mr. Farooq Abdullah Sultan, Logistics and Supply Chain Specialist, and Dr. Ajay Verma, Associate Professor, Manit Bhopal, Madhya Pradesh. Uh, may I now request Dr. Satyendra Sharma sir to welcome our guest.
Okay, thank you, ma'am. Uh, Farooq sir, on behalf of Sage University Indore, Institute of Engineering and Technology and Institute of Advanced Computing, I welcome sir. Heartily welcome. And thanks for sparing your valuable time for all of us.
Thank you very much, sir. It was my pleasure.
Sir,
Thank you for
before
sharing the
starting,
wonderful video.
yeah, thank you, sir. Actually, Sage Group is a very big group. They are having a variety of avenues and they are working in different areas. Right now, in academics, we are having two different universities. One is in Indore, one is in Bhopal. We are having two international schools in Bhopal, having a hospital at Bhopal. They are having working in construction. They are having in power. Sage Power Group is also there and also working for society in as a True Sage Foundation. So it's one of the kind of big group in Central India. So before starting, I just want to introduce yourself. So all the participants, our today's speaker, Dr. Farooq Abdullah Sultan, is a researcher at Chalmers University of Technology, Sweden. He earned his PhD from BITS Pilani, specializing in supply chain design and optimization and holds a master's in advanced manufacturing from Sastra University and a bachelor's in mechanical engineering from PS Abdur Rahman University, Chennai. With extensive teaching and research experience across engineering and management disciplines, Dr. Sultan has previously served as an assistant professor at NMIMS and a visiting researcher at Sintef Ocean, Norway. His research focuses on sustainable supply chain management, circular economy, and reverse logistics, addressing real world industrial challenges. His session will provide valuable insights into greening the supply chain for sustainable logistics in the electric vehicle industry, focusing on optimizing supply chain efficiency while reducing environmental impact. So, with these words, I request Dr. Farooq to just start the session. Now, sir, session is over to you.
For sure, sir. Thank you very much once again for the wonderful
Thank
description.
you.
Thank you very much. Yeah, I'll just share my screen.
Yes.
I hope, yes, just a sec.
Yes, sir.
Yes, I hope both my
It's
screen and my voice both are visible and audible.
yes, sir. It's perfect. Perfect.
Perfect. Just a sec. Yes. Try to do this. Yes. So once again, welcome you all to this session and thank you for inviting me for this session where I get an opportunity to share and discuss with like-minded people like all of us working on this domain of supply chain management, where I would like to focus on, as per the topic given, on sustainable logistics. This is going to be a 1 hour lecture, so I thought let's try to make it a bit interactive. So that's the reason that you see over here. So what you could do is before we jump onto the lecture, in order to just understand the type of audience that we're dealing with and to understand the expectations, I was just wondering if you could just take out your phones, scan the QR code, and give in your inputs with the question that you see over here. It's a pretty basic and simple question. So I thought let's try to keep it a bit two-way around. Though talking and interaction would be difficult in a 1 hour long meeting. So I thought this is one way of going through, of discussing, of what do you think? And obviously, I'll be there for the discussion at the end. Sure. So you could just scan this QR code and just try to answer this. The same question would be there on your cell phones. You just try to answer it. If it's okay for everyone, obviously. Perfect. So at least we get to know that the biggest challenge in greening the supply chain, as almost it's wonderful to see that everyone is on the same picture. Cost of implementation is same thing. Oh, it's not done yet. Okay, fine. I'll just keep silent for some time and wait for
Yep,
everyone to respond.
actually, because of some network issue, maybe the scanning of that
Okay.
code is
Uh,
delaying.
okay, fine. So I'll just keep on moving on. So at least right now we have just a picture that cost of implementation is something that everyone feels is a problem, which is actually true. Just trying to ship slides right now. We would like to see and understand that supply chain sustainability is something that is of great problem. Each and every supply chain that we talk about, or what we read about, or what we see about, talks about issues of sustainability. And when people, or say researchers like us who are over here, try to explore and see what the reasons of this sort of issue of sustainability in supply chains arises, n number of researchers come up with n number of aspects. Financial concerns, as we all pointed out, yes, it's an issue. Apart from that, there's a lower intention of people who want to move towards these sort of products. Other type of and some directly pinpoint at the male gender and state that men don't want to go for eco-friendly products. So there's a huge, what you say, diverse view into this aspect of why sustainability has not been into picture. So, in the need, before we go, I would like to just break the point over here and say mention that I planned the lecture in such a way such that we just go from the basics a bit and then we jump onto the EV, if that's fine for everyone. That's how I try
Yes,
to
it is.
position this. Yeah.
Definitely.
So, yeah. Thank you, sir. Thank you, sir. So, when we go into this concept of sustainability, the major issue comes over here, as you see, is that the resources are infinite. The demand is also infinite because we as consumers have this huge tendency of demanding each and every time thing that we want. But at the same time, the earth, the mother earth, which is providing us with all the necessary resources, that's not infinite, that's finite. And that's a reason where sustainability, or say greening the supply chain, or say trying to use resources in a sustainable way, comes into the picture. Now, jumping into a bit more deeper into the topic, when we tame the terminology of green supply chain, we actually mean it's a simple process of environmental thinking, having the environment into consideration while the different processes. So it basically it derives from the green activities in procurement, greening the manufacturing process, or say greening the logistics, where you try to do all these sort of supply chain sort of activities in a more sustainable way. And every sort of sustainability aspect that we try to put out, we try to be much more clear that it's basically on is reducing the utilization of the resources, and also at the same time having control over the environment. Now it's a holistic method, so where we don't try to just pinpoint at one point, try to take the whole system approach and try to see where we are to improve the sustainability aspect. In short, sir, and everyone, ma'ams, who are present over here, you might be all aware that greening the supply chain is a difficult task. Though we have a number of researchers who are working on this day and night, or some might say that greening is a part, it's an older topic and we need to move to a newer one. Greening supply chain is difficult. I'll try to just go on with a simple example. Let's take up a relatively complex, say relatively easy sort of supply chain where we have one consumer trying to buy a product, material flow, he gets a material, and at the end of the time, there's a cash flow. And this goes on and on upstream. Now, when you have a number of consumers trying to bring in end demand types of products across a relatively complex sort of supply chain, the issue arises of how do you track sustainability? How do you track circularity? Any number of aspects come into the picture. There also comes to a point that we as consumers might be demanding or might not be demanding, but we in the whole perspective need to understand this point that though either we, irrespective of the fact that we are demanding or not demanding, we need to consider the fact that the resources that the universe is providing us or the earth is providing us is limited. Now, the question in terms of a supply chain aspect comes into the picture of how do we actually try to understand this or how do we try to trace this? This is a relatively a tough task. Two examples, two different stories. H&M, the one that you see on the left, something called the Rana Plaza incident, something related with such H&M, where they had to face a huge backlash some years back when they found out, when the whole world found out that the supply chain it doesn't actually try to understand sustainability. It doesn't try to consider sustainability, only for the fact that the supply chain is pretty complex. You as a consumer are somewhere in Europe or in Sweden, but at the same time, the whole producer, who's taking place in this production, is somewhere in Bangladesh. How complex, it's a complex supply chain, and trying to understand whether sustainability is actually being incorporated over there is something that is a bit problematic. Next, we need
Excuse
to
me,
move on
sir.
to the, yes, sir.
The loudness is very low.
Okay, sorry.
Maybe there is
Is it fine right now?
little bit better. Yes, sir.
It's better. Just a
Yeah.
sec. Just a sec. Okay.
Maybe the distance of microphone is little
Yes,
bit
I think.
more.
Yeah, I think that's the problem. Now it's fine. I hope so.
Yeah. Yes. Yes.
Yes, perfect. Now
Yeah.
we
Thank you,
jump
sir.
on to the,
Sorry.
yeah, it's okay. It's okay. Totally match. Please point any issues to me, Satyendra sir, because I won't be able to see the chat window. So that would be an issue. So
Yeah.
please
Yes, sir.
just drop. Yeah, please
Sure.
feel
Sure.
free to just drop in anytime. Okay.
Thank you.
Yeah, yeah. So this was one problem which H&M placed earlier with sustainability, and then we had another issue recently with Nestle and Hershey having this sort of same sustainability sort of impact of resource utilization, and no one had a clear picture of what and where the sustainability issue was rising. So in short, what I mean to say over here is the whole sustained supply chain is pretty complex, and trying to understand each and every member, what each and every member is doing, it becomes really difficult in a whole complex sort of thing. Challenges are many. As some pointed out, money is the major impact. But if we go through, try to dig into deep into this picture, we try to see that resources, waste, energy, social aspects, information, what and all we see over here are problematic over here. Now, I would like to take this lecture into some aspect that I try to work on, which I would try to correlate with at the end. But so please bear with me at least at this point of time right now. So one aspect where we try to take control of this sustainability is by trying to incorporate the concepts of circularity. Now, the whole world, if we try to see, has around 1.3 billion tons of waste being produced every year. And there's a strict need for us to shift towards sustainable sort of production. Circularity comes with as a handy picture where we try to use reuse, reduce, recycle, redesign, remanufacture, and repurpose as some of the circularity parts of our. Now, circularity as a whole concept is quite big, so I'll just try to just stick on with this one and try to move forward so that we could try to discuss this at the end when we try to relate this with EV as a whole. Now, the whole concept of circularity, if we try to take, is to move from the take, make, and waste model of where we just try to buy a product, use it, and throw it, apart from trying to make the product, extend the life of the product in such a way such that you try to use it for n number of lifetimes. Even if the product goes to the dump, you try to take the product, you try to repeat the product or say reuse the product in such a way such that the whole economy of take, make, and dispose gets converted into a circular cost sort of thing. A simple depiction of what what we are trying to focus on of completing from a linear economy to a circular sort of economy. Now, the main thing that we need to see over here is like completing into circularity is not just about revamping the supply chain. It's not about just bringing in transportation. It's not about bringing in good researchers or say good supply chain engineers. It's about redesigning the product. in such a way such that it tries to accustom on and it tries to adapt to this concept of circularity, which we'll be trying to say again. Now, people or say industries are trying to follow this, as we should see different ways or say different techniques that industries follow or say organizations follow in order to include this circularity. One that you see over here is that we have the current take, make, and dispose of linear supply chain. Then we have something called the closed supply chain, which to an extent is tries to go towards circularity, but not that much because at the end of the day, there is no control of the product. And over here, we have a circular supply chain, which as a producer has a complete control of the product, where the primary resource, the circular resource, and all sort of flows are taken control of. And in short, we have a zero waste. Now, if we try to look into, again, jump into researches before we jump to sort of EV thing, people say that sustainability could be incorporated in three different ways. One, as you see over here, is an open configuration where you have a buyer, you have a first tier supplier, sub suppliers, and the first tier supplier tries to take care of the sub supplier in terms of sustainability. Then we have the third party configuration where we have a third party trying to take care of the whole process, but still over here, we don't have a complete visibility. And again, we have a closed configuration where everything comes under the single picture and the whole supply chain is actually taken care by the buyer and the suppliers involved. Now, jumping into the main hero of our topic, the electric vehicles over here. Now, if we see electric vehicles as the topic suggests and something that we pointed out has been into this picture, has been to this theoretical picture of bringing in great revolution into this whole world. Be it use of consumer friendliness, be it in terms of economic sort of long-term long-term economics, in terms of sustainability. At least the media at least tries to portray that electric vehicles is the nearby future, nearby sustainable or say good future that we have. Now, when we try to look into a bit deeper and try to demystify the myths that goes on, we have two pictures over here. One tries to amount of transportation, road transportation that cars usually try to contribute, or say we have these four-wheelers trying to contribute, with around 80% at least of the chart being comparted with vehicles. And the other way, we have a study from, I think it was the New York Times, where when I tried to look into, which states that the electric vehicle supply chain has a dirty secret. Now, I would like to ask you this question. Are we on this right path of moving from this sort of conventional vehicle to a electric vehicle only with the point of view that my vehicle runs on electricity? The answer is, if we try to see, we might have different answers, and that's the reason I have another question for you, all of you, to keep it a bit more interactive. How environmentally sustainable do you think are electric vehicles? Please take in your phones again. Sorry for interrupting you. You might be. I didn't want to disturb you, but I think it would be better if we all are interactive, at least on this stage. So, how environmentally sustainable do you think electric vehicles are? Now, your cell phones, again, the QR code, do you have it? And yes, we can go on with the poll. We'll just take one more minute before we try to jump on slides and try to explore.
Yes, sir.
Yeah. Perfect. So I think that's what, at least we are at least clear as a whole audience that environmental sustainability, we are somewhat sustainable. Now the question arises, when we are talking about sustainability, what do we actually mean by sustainability over here? But this is one of the interviews that we had some years back when we were working on a research project. And this is what they had to say. It's actually of trying to have this sort of environmental sort of thing at one point where you try to say that the whole Europe is doing good because we have, or say Europe has transitioned to an electric vehicle sort of thing, or say EV sort of production of transport. But it actually means, or in the other way around, we are trying to shift the environmental impact somewhere else. No one tries to take into consideration where the environmental materials have been mined, or say no one tries to take into material consideration where and how this vehicle will be tried to say will be brought into the loop once its life gets over. Because the major problem with EVs, as we see over here, is the battery, which no one talks about, and pretty much less amount of research has actually gone through. Now, when we try to dig in a bit detail into the influence of, say, the emissions that we are wondering about, we might be talking about different types of emissions. Obviously, the reducing the emissions when using the vehicles during its running time or current life. And also we talk about reducing emissions when during its production, transportation, and reverse supply chain. Now, the problem is this one, where no one wants to talk about. Reducing emissions when using vehicles, yes, it reduces. You have literally very less amount of emissions because you use electricity. You don't burn any sort of fuel. But the problem is what happens with the emissions that is being used in production, that's there in transportation, and that's also happens in the reverse supply chain activities. We as researchers generally, we as consumers, I won't blame the researchers, we as consumers generally try to at least come off with a picture because no one, as at least the media outlets never try to show us, at least they try to show us the positive aspect of this. The challenge of EVs comes with this. If you see, go through this picture, it has lots of amount of data. It tries to at least give us the picture that the end of life, sorry, the total amount of emission produced by the vehicle is comparatively lesser than what we have with internal combustion vehicles. But the problem is no one tries to focus on this aspect, the end of life aspect, especially with the battery manufacturing, which is by far the most resource consumptive part, and also at the same time most environmentally degradative part. Now, in order to make it zero emissions, we need to reframe or say redesign the supply chain in such a way such that we have everything in our control, basically from production to extraction of raw materials, designing of the vehicle, same time use of the vehicle, and also at the same time the end of life of the vehicle. So the whole system that we see, right from extraction of material till the dispose of the product, everything must be within the picture of the supply chain. But whereas, as we see right now, at least to an extent, the production is within the control, the manufacturing is within the control, sorry, the extraction of raw materials is within the control, the production is within the control, the dispatch is within the control, but at the same time, the end of life is something that doesn't really come into the picture. And that's where many people have tried to question, say, right, do we need something called the battery passport, where we actually try to capture where the battery is and how far the battery is doing, and say, where are, which basically comes to a picture of crucial to create visibility in the supply chain. And that's where I would try to take the attention of all our noble dignitaries over here of what could be done a way forward. Something that we see, it's a change is to identify, as it control the whole production of battery production. And that is where one of the whole impacts of environmental sustainability comes into when we talk about automobile EVs generally. A way forward, as I mentioned earlier, is by circularity, where we try to redesign the whole products, where we try to redesign not only the supply chain, but also the way in which the product is designed. One such way that we can go approach is through sustainable logistics. Though I would have, obviously, many dignitaries from over here would try to say that approaching this problem could be done in any way. We could bring in route optimization, we could bring in this thing, we could bring in that thing. But one way that really tries to take a forward, and which I'll be trying to explain with one of the companies who are also trying to do it, so that we as an audience get an idea of one possible way which could be attained to of sustainable logistics. Now, one aspect of, say, of bringing in circularity is by adopting the principles of procurement, of where we as individuals try to take in procure materials that are pretty sustainable, and obviously at the same time we try to make this sort of contracts with existing suppliers of having either raw material contracts of giving the good quality sustainable materials, but also at the other end having sort of a rent and lease method, which some people say is a sort of circular procurement. Because one of the major problems that happen in a battery supply chain is that there is the ownership is actually transferred to the consumer, who at the end of the day doesn't want to take responsibility. Obviously, because they are taken responsibility means trying to invest more money. So there is a particular sort of research which tries to tell that your system level or say a contractual method of where you try to rent or lease the supply, you rent or lease your product is something that could be done. The other way, we have the supplier level, where the supplier tries to bring this sort of track back mechanism, or say where the supplier tries to have the control of the product and tries to see which and in where is the product, or say the battery is located, or say which stage of life it is. And at the product level, which eventually takes us as a group to the previous discussion that we had of designing it in such a way such that it is environmental friendly. We use sustainable materials. At the same time, we use sustainable logistics. We use sustainable sort of way of handling the material, sustainable way of disposing the material. So a number of aspects come into it. So system level, supply level, and product level. And there might be a question, sir, like, is it possible that we try to take one into picture and try to other try to neglect it? It brings chaos. We'll be trying to look into a company, as I mentioned earlier, which tries to do such these things, and it is successful at one instance. Then obviously, when we try to talk about sustainable sourcing, we obviously need not forget about the procurement criteria regarding both about the material selection of what type of materials we are using, and also about from where do we actually try to source those materials. Either it's a local sourcing, we have ethical suppliers, and supply diversity is something that needs to be maintained over here. Apart from circular procurement, we also need to have this sort of design for circularity, where the major idea or say major concept is of elongating the life of the product to an extent that a product doesn't loses its life after one of its life cycle. So you try to design a product in such a way such that it has multiple lives, such that if one of its lives gets over, you try to retract the materials from its and try to reuse it again. So the product design is one aspect which could try to help us. You have a material which is easily disassemblable. For example, we have e-waste in India, which, for example, India is one of the largest producer of e-waste. And the major problem that though we have the infrastructure to manage this e-waste, problem that we as a country face is that the products that generally get landed up as e-waste don't have the design for it to be disassemblified. So design for disassembly is a concept which comes over here too. Sustainable packaging is also another aspect that we need to focus on in order to, what do we say, in order to make this logistics as design. So as I mentioned, optimization, route optimization, network optimization, those are n number of ways of tackling it out. But redesigning the reverse logistics, or say trying to have a green logistics where we try to produce stuffs in a sustainable way and also try to deliver products in a sustainable way. So when we try to take this into picture, we have this idea of reverse logistics come to the picture, which by far is one of the most toughest things in in actually trying to bring in this severity and trying to elongate the life of this product. Because you at the end of the day don't know, you might have a car which is being produced in Chennai, for example, and at the end of life stage it might be there somewhere in Shimla. Now the question is, who tries to bring in the product, who tries to bring in the end of life or say end of life product from Shimla to Chennai, who takes the responsibility? So those are some aspects that we need to take into consideration while trying to design this green logistics. And this is where the concept of circularity could help us in one way. There we come as one of the most common ways, or say one of the most proficient ways of using product as a service, where we try to bring in the concept of circularity. Also at the same time, we try to strike the balance of focusing on environmental aspects, economic, social aspects, a bit diverse, but also at the same time, the ownership of the product is not transferred to the consumer. In short, the whole problem arises over here when the ownership is transferred to the consumer. And many researchers try to say that if the battery supply chain needs to be made a bit convenient or say a bit more sustainable, product as a service is one way forward. Let's look at one example of a company which tries to do that. Volvo. Though I would say that we don't have a sort of setup in India, in Sweden, where I work with, we Volvo tries to come up with products which tries to propagate as product as a service. where you as a consumer try to pay a subscription, you try to get ownership of the product, but you don't own the product. Now the question arises, sir, how does trying to take ownership of a product tries to solve this problem? Now what happens is, if you try to design a product in a circular way, you try to design this product in a sustainable manner, but the problem is when it tries to change hands, the whole thing happens here. You don't know what happens with the end of life. Using products as a service, what companies try to do is they try to take complete ownership, and you try to pay just for the service, where the company has a complete ownership of the product. It has ownership of each and every component that is being involved. So you as a consumer don't need to take any responsibility, but whereas as a supplier, as a manufacturer, Volvo over here takes the same responsibility of using products as service. I would like to point out that this concept of circularity is not something that's completely custom or say it's done by Volvo itself. Many players, such as Philips, has tried to bit into it, because concept of circularity of maintaining or say increasing the life of a product apart from the make and dispose to this circular life of having continuous lives, or say elongating the lives of the product, has been something that has been valued as this as a way of moving forward. Trying to look into the complexity of the battery supplier in Europe, this is a small picture of how what complexities are we trying to actually go through it. You have the raw material supplying the raw material, you have the manufacturer, you have the EV battery. This is a whole loop. And managing this whole loop comes into a picture only upon an instance that if someone has a control. Now the question is, who takes the control? Product as a service is a way forward of taking control of the product. A bit deeper again, we try to look into this whole magnanimosity, the whole complexity of this whole supply chain. The raw material coming up, the battery OEM, the EV OEMs, the dealerships, and all those stuffs. It's a whole complex part. It's a whole sort of, I won't say it's a mess, but it is a whole complex supply chain that needs to be taken care of. Now, with circular materials, with circular raw materials, with circular sourcing, sorry, yes, with circular raw
No, sir, no,
material,
sir.
yeah, with, yeah, with circular raw materials, with circular design, and all those stuffs. Now comes another question: that how do we actually know which a product which is actually bought in Chennai, what stage of life it is in? Again, to the same question in Shimla. Okay, there is one way of going forward where the supplier or say the producer or the manufacturer takes control of the whole product and has the whole complex thing of what we see over here into the picture. And there comes also other way of handling this problem. So circular practices in EV supply chains could be many. So you could bring in circularity, you could bring in legislations, reverse logistics, the different R's, the consumer awareness, a number of aspects could be brought into it. But in order to implement it, or say in order to full-fledgedly capitalize on it, just bringing in circular practices also plays an issue. Just bringing in a design concept, just trying to bring in legislations, also brings in a complexity of how do you know which stage the product is, say how which stage of life the component is, or say which stage of life the EV battery, or say the EV vehicle that we're working on is. Everyone wants change, but who wants to change? That's a tricky question. And that's also we as practitioners of knowledge and say practitioner of engineering practitioners, say supply chain practitioners also face. We know that there is a change that's necessary. But at the end of the day, who wants to change and who wants to take the initiative? That becomes a tough task for all of us. Now the question arises, okay, we have this concept of circularity, fine. We have this concept of product as a service, fine. How do we achieve this? A recent trend that has been going on has been to move towards sort of digital transformation towards achieving this, where Volvo, if say for example, Volvo or say Philips has a complete track of what is the status of the product, in which stage of life it is, though it is serviced and though it is managed, which stage it is, which stage it needs focus, which stage it doesn't need focus. A way forward could be via digital transformation. So while we say digital transformation, we have this end-to-end visibility as everyone is aware of, and making the supply chain digitalized, where you have the ability to quickly respond to changes. Say, if you think that one of the batteries in Agra is for is almost towards the end of life, you as a consumer, you as a producer have a visibility over there. Yeah, there is something going on over there, and we need to take control of that. Obviously, it's not just about visibility, we also need the infrastructure. But what I mean to say over here is a way forward over there. So with digitalization comes the end-to-end visibility, where a supplier sitting in Chennai or say sitting in Delhi has a complete picture of what is the status of a product in EV, or it might be the battery. I'm just focusing on the battery right now because I still see that to be a most resource intensive component of the whole EV supply chain. What is its status and which stage it is? Because if we see over here in India, generally, or say any happens, the main problem is, or not say only in India, I don't want to blame our country only. The whole problem in generally what happens is we try to buy a vehicle, we try to have it serviced, and at the end of life, we try to send it to a kabadiwala or a garage or somewhere where the garage person or the garage bhaiya tries to make use of that EV battery, tries to reuse it, and at the end of the time, he tries to dispose it. And there comes the major problem where digitalization actually tries to help us with, of trying to understand which product is where and what needs to be taken, what action sort of thing could be taken off in order to solve this problem. Some benefits of digitalization, obviously better sourcing plans. You actually know like what needs to be procured and what how much demand is there. You have this transparency of where you try to see and completely picturize what needs to be done, which status my product is and what needs to be done to solve it. And obviously reduce the adverse environmental impacts, something related with sustainability aspects. So a number of aspects here and there could help us trying to solve. And obviously we have beautiful number of solutions. What started with blockchain, IoT, we have AI solutions everywhere to help us solve this problem. Now translating the whole thing into an Indian perspective, the whole translating the whole concept of circularity, concept of digitalization, concept of n number of aspects that we see into an Indian perspective brings in n number of new problems. Raw material dependency is one aspect, supply chain fragmentation is other one, environmental regulatory concerns, technology and manufacturing concerns, infrastructure and cost barriers. Now I would like to reiterate to what we discussed, or say what we at least told in the initial part. We have a perspective that cost is the only issue. It's not just the cost. There are n number of aspects. Thus, we'll just trying to focus on the raw material dependency over here itself. Circularity comes into a picture when you have ethical suppliers, when you have ethical sourcing, when you have local sourcing sort of stuff, which I agree we have in India, no doubts on that. But what happens is this dependency factor. When you have this sort of dependency, when you have the sufficient amount of resources, especially with global catastrophes such as COVID-19 and say other geopolitical issues rising up, you need to have your suppliers somewhere in close locality. But whereas if we see in India, we do have, I don't say that we don't have, we do have a couple of sources, but there is this dependency on other countries too, where we don't have the capacity to serve this huge, beautiful market that we have in a country. Now there comes the other picture of circularity. How do you do source your materials? Yes, we have our suppliers. We have beautiful suppliers in India. We have the beautiful capacity in this beautiful country. But how do you actually try to manage the huge capacity, or say the huge demand that is being there in this beautiful country? Obviously, you try to do your local sourcing to a massive extent, but at the same instant, you try to go outside the country. That creates a problem. And one of the issues in India, or say one of the problems in what most of the developing nations, though this study that I try to take in from focuses on India, is supply chain fragmentation, where each member of the supply chain has its own agenda. The retailer tries to focus his or her own profit. The manufacturer tries to focus on his or her own profit, and at the same time, the end of life partners tries to focus on their profits. Now, when you have such sort of fragmented nature, when you have different sort of, when you have a misalignment in what you want to achieve from the supply chain, there becomes a problem of each and every stakeholder try to focus only on profit. And at the end, you have a supply chain which tries to bring you the profit, but in an unsustainable manner. And obviously, causing huge degradation to the environment. And the other ones, environmental regulatory concerns. Though we have lots and lots of regulations coming up, at least recently, we have lots and lots of strong trust regulations, which actually would bring in a huge toll to the manufacturers, or say manufacturers or say producers of these EV vehicles, another question starts to arise of say how long will it take for these sort of regulatory concerns to get adopted? So we are not blaming the government, but we are blaming the adopters. How long will it take to get complete regularized? Because even when we had this sort of transition from the engines, from the Bharat BS4 engines to some of the recent engines, there was some time limit. Now we are talking about a country which is huge, which is huge. How do we actually try to bring in or say implement this? And how long does it take for this to implement? Then comes the technology and manufacturing constraints. Though we have gigafactories being set up in Gujarat, in parts of our country, in localities of the country, the technology that we need as a whole, because I was reading one of the newspapers some days back, we are having gigafactories coming up for battery. Ola is trying to set up one, if I'm correct. There's also other industries which are planning to. I don't remember whether it's Tata trying to set up another one in Gujarat. I don't remember, but there are these huge things going on, and the question comes, till that huge gig factories come into picture where the whole EV thing is circularly procured, circularly manufactured, circularly designed, and circularly implemented, what happens to the products that are already there into the market? Who takes responsibility for that? That's a problem that we face. And obviously, the cost and infrastructure barriers, as every one of you rightly pointed out, that's a problem. Now, there are n number of perspectives that we need to take into consideration while trying to solve this picture, at least in the Indian perspective. Now, I didn't want my whole sort of things to of mathematical stuff, everything to come into picture. That's the reason I try to just keep it as basic as possible. Now, again, I as a general audience, now I would like to be an audience right now. I would like to ask you, what do you see government policies could improve EV recycling? Again, sorry for the interruption. Please take in your phones and start scanning the QR code. And
Sir, options are not displaying.
yeah, it's just an open thing.
Okay.
Yeah, what we feel, what we think.
Hello.
Yes.
I think the policy, like Indian mentality, is one of the aspect,
Mhm.
uh, right? So that
Yes.
has to be intensified in certain way
Mhm.
that it provoke the users to go for it, because
Mhm.
monetary aspects definitely pull out the people
Exactly.
towards that.
Yeah,
So
exactly.
that could be one of the aspect that policy should be governed in that
Mhm.
manner.
So you mean to say monetary policies in order
Yes.
to attract people? Perfect.
Yeah.
Yes, that's one way.
And
St-
moreover, the awareness is one of the aspects. Like, we are not that pro EV right now,
Exactly.
even though the policies are there, but we peoples are not pro EV. So
Exactly.
the benefits should be transmitted towards the general people so that they can adapt in a better way. That's through government policy.
True, true. But I would like to iterate this upon this, sir, that even though we are not into this huge rush, the whole market seems to be going in such a way such that one way right now we might not be there, but in the upcoming 5 to 7 years, we every consumer would be behind this EV magic that's being revolutionized in India.
Yeah, yeah,
So yeah, that is one
yeah,
thing.
that's
Yes,
right. But
yeah,
yeah, but I have a concern that before that rush comes, the
yeah,
awareness should be that
true,
point
true,
that it
true.
can leverage out
I
that
I
potential.
agree. I totally agree with you.
Because
Yes.
if 6, 7 years are down the line, we are seeing
Mhm.
ourselves to that point. The
Yes,
government's policy should be in place right now so that
exactly.
it can cope
We
up
are
at that point.
exactly, sir. We should be pretty much aware before the mammoth strikes us.
Yeah.
Yes. Yes, I think that's only from my side. I tried to keep it as short as possible to avoid boredom. And that's it. And now it's the time for us to take action. Any queries, I'm happy to answer.
Sir, it's a fantastic idea, sir.
Thank you, sir. As I
So,
mentioned, this is a huge topic. This is a huge topic where every researcher tries to go in his or her way. This is one way that we adopt, or say that is one way we think that this needs to be taken into consideration. Because I totally agree that circular procurement, or say circular sourcing, is something that might be very easy on paper. It's very easy to present just a couple of boxes and say, yeah, we need to go this thing, we need to do this thing, we need to do that thing. But actually trying to bring this into implementation is something, is a huge challenge that we all, not only India, but every country, or say every nation, tries to fight up with.
very right, sir. Participants, the question answer forum is already open. Please, if you have query, please come forward.
You please feel free, anyone, if you have questions but it's still in a bit of a hazy stage, please feel free to drop me an email and I'll be happy to answer.
Sure, sure.
Yes, sir.
Sir, one thing that I think we should focus on, like if we down the line we are seeing for 7, 8, or 15 years down the line,
Yes, sir.
is possible to look after the consumer who are right now maybe in 10th, 12th standard, they
Mm-hmm.
will be in a position to go for those EVs vehicle. So
Mm-hmm.
is it way to go into the schools and colleges somehow and means mind up with them, aware with them, then how the after 5 or 10 years down the line, how EVs are going to be a part of your daily life, and if the we can manipulate out their mind
Mm-hmm.
towards sustainability,
Mm-hmm.
and they by the time they reach that point, it will be more easier for the country to actually be more aware towards that EV booms or whatever we looking after.
For sure, sir. I totally agree with you, sir. I totally agree with you. There is not even an iota of doubt that what you pointed out, that nurturing must be done even from the grassroots right now. Because the mammoth that the huge impacts that a battery can create is something we are aware of, because we do have these sort of batteries, and we do try to deal with sort of inverter batteries, car batteries, and all those stuffs. But when we have this EV boom, things will get more catastrophic. We will have, in place of 100 batteries in a place, we'll be having 1,000 batteries. So
Yeah.
as you mentioned, rightly pointed out, sir, that is possibly one of the best and one of the foremost way that we must take into consideration, especially considering the huge dynamics of a country, the huge diversity, the beautiful diversity of a country where population obviously is high. There's a huge variability in the types of people also. It's like friends from the east are different from the west, friends from the north are different from the south. This sort of
Exactly.
discussion, I totally agree with you, and this is the one of the possible and the best way that we should go forward. Might be difficult, yes it is difficult. Might be costly, yes it is costly,
But
but
if
considering
government, yes, but if government push out such kind of programs
Mhm,
where it want to handle this situation after 10, 15 years, I
mhm,
think it won't be that difficult, because being technical people knowing about it, it is better let the consumer be prepared for it
mhm, mhm, mhm.
before it comes.
Yes, sir. And also, we also need to make sure that before the consumer, because we usually have this point that the consumer needs to be aware of that. I totally agree with that, sir. But for the consumer to be aware of that, it also becomes necessary that the necessary infrastructure is also already there and available. So that once we have an end of life battery, though we don't talk about EV batteries that much right now, we do have batteries right now in our environment. We also do need the infrastructure that needs to be there. So that is also something that also needs to be equally focused on. Both knowledge nurturing, both in terms of grassroots level, and also at the same time, the required infrastructure needs to be there, needs to be made available. And obviously, the government of India is doing a beautiful job. And obviously, we need to step out with it and join hands. It's a tough task, but nothing impossible.
But it is possible if we all comes together. it won't be that much difficult.
Yes,
If the academia, industry, government all pull up
exactly.
if together, it won't be that difficult, I think.
Exactly, sir. Exactly.
Sir, in Indore, in few government schools, they have started one subject on electric vehicle
Uh-huh.
in ninth standard and 11th standard.
Wow, that's nice to know, sir. Wow, that's
Yes,
good.
sir. And it's
And
they have like given it as a elective.
mm-hmm,
So few of the students are taking interest in that. Even
mm-hmm,
I visited a government girls school,
mm-hmm.
and they invited me for a guest lecture.
Mm-hmm.
So I was wondering, and it was really very nice experience with those students. They were really interested in knowing many things.
That's nice to know,
So
sir.
it's a
It's nice to
government
know.
initiative. They have started already, sir.
Wow, that's wonderful. That's wonderful.
Yeah, yes,
That's wonderful. And that is one way
Yes,
I think, and as one of our participants rightly pointed out, that's surely a way forward. Because until and unless an awareness is created, it becomes totally difficult. And
correct.
yeah,
Okay, so any other participant wanted to share his or her view? The forum is open. I think no any other participant is interested. So let us come to the closure of this session. And for that, I would request Dr. Amit Bhayakar, co-head in the Department of Mechanical Engineering, uh, for a vote of thanks.
Thank you,
So,
Ratan
Amit
sir.
Bhayakar, sir, it's now over to you.
Thank you. Thank you very much, sir, Farooq Abdullah sir, for sparing valuable time. Also, you have just select a very good topic, that is logistic and supply chain. It is a very popular and burning topic nowadays. So many research and things are going on this logistic. So this is very informative session for our participant. You have very clearly and particularly explained that some things which I very much like, and I also take the screenshot of that also, that you have particularly explained supply chain models. I very much
mm,
like that. Also
thank
that
you, sir.
circular supply chain diagram also you have
Mm,
very clearly and specifically explained. In spite of that, that circular procurement, these things are new for us.
mm,
Circular procurement, and another this that various circular practices that we have adopted and that show in the very graphical representation, that I like very much. And also that participant will definitely get help with this topic, and they also uh, find the new way for research and that for career. Definitely, sir. Thank you very much on the behalf of
my
Mechanical Engineering Department of Advanced Computing and whole Sage University. I really thankful to you for sparing a valuable time for us. And in future, definitely we will take such session and further sequel of this topic. And thank you for all of us. Thank you very much, sir.
it's my pleasure, sir. I have heard I guess I'm getting a echo, sir.
Yeah,
And
yes.
someone could mute it.
Uh, just wait, sir. Let me try.
Yes,
Maybe
thank
due
you.
to, yeah, yes.
Yeah,
Now
thank you,
it's
sir.
clear,
Thank
sir.
you. I have heard, I would like to first of all thank you. Thanks everyone for giving this opportunity. I have heard a lot about Sage University. I had friends when we were doing a PhD at Bitspulani. I had friends who previously worked at Sage and were doing my PhD. So I have learned a lot about
Okay,
Sage, which I'm very happy to contribute and be a part of it. But I also saw some chat messages regarding presentations. I would be very happy to share my presentations.
okay. Thank you so much,
So,
sir.
Satyendra sir, just let me know where I should put it. If you
Yeah, you can send me
then
personally.
sure,
Then
I will
I
share.
will share it in the group.
Sure. And in case if anyone has any queries, you can just please feel free me to just send me an email and be happy to help contribute it the best way possible from my side.
Yes, sir. Maybe some researcher working on the same topic, they wanted to connect with you.
Yeah, for sure, for sure. Just drop me an email and be happy to help.
Definitely, sir.
Sure, sure.
It's a really very nice presentation from your side, sir.
Thank you very much, sir. Thank
Thank
you very
you.
much.
Thank you so much, sir.
Thank you. Take care.
Okay.
Bye.
So now, moving forward, as the second session will start after half an hour, so we'll just wait that the second speaker join. Till then, you can wait in this meeting or you can rejoin at around 7:30, 7:25.
Good evening, Sarva sir.
Yes, yes, sir. Acha, Ajay, sir.
Uh,
Oh, yes, sir.
Ajay, बोल रहा हूँ.
Sir, welcome,
So
sir.
if it is possible, we can start right now. I'm
Okay,
ready.
no issue.
But
No issue, sir. Arey,
please ask
thank
the
you.
participant whether they are ready or not.
No, no, sir. It's very nice to see you that you have already joined. Thank you so much, sir.
Me too, me too.
So, yeah, the participants has answered that they're ready, and
Okay.
it's very nice. So, I just request Dr. Amit Bhakar, sir, for welcoming our second speaker, Dr. Amit Bhakar, sir.
Thank you, Satyan sir. Uh, on the behalf of Sage University, Department of Mechanical Engineering and Advanced Computing, I heartily welcome Dr. Ajay Verma sir, Associate Professor, MNIT Bhopal. Heartily welcome, sir, in the Sage University.
Thank you, Amit.
Uh, your topic is also, you have chosen very informative, that is challenges and complexity in the electric vehicle supply chain. Just we have listened supply chain, now we are get opportunity to learn more in the supply chain, and also that
Challenges.
complexity is, I like more that if complexity is there, always solution is there. So we will eager to learn something new than complexity or solution.
I'll
So
try,
welcome,
definitely.
sir. Welcome, sir. Heartily welcome. I request Dr. Satyan Sharma, sir, to give the brief introduction about the Ajay, sir, and start the session.
Yeah, definitely. And before that, I have one information that Dr. Amit Bhakar, sir, is one of the alumni of MNIT.
Oh, wonderful.
2004 pass out batch, sir. 2002 to 2004 in maintenance engineering. MTech in maintenance engineering. 2004 pass out.
Nice.
I have done the thesis in the Dr. CM Sadiwala.
2004 means.
2004 pass out.
Okay. I joined Manitou in 2010 actually.
Okay.
So, Dr. Ajay Verma, sir, currently he is working with MNIT as an associate professor in the Department of Mechanical Engineering. And he is, yeah.
हेलो
Yes, ma'am. Welcome, ma'am.
अजय सर को देखकर इच्छा हो गई बात करने की.
Yeah, yes, ma'am.
Is it
Definitely.
Ati Jain?
अजय सर को मैं याद हूँ.
अति जैन बोल रहे हैं? कौन बोल रहे हैं?
No, Dr. Suman Sharma, madam.
ओह सुमन मैम. ओह यस मैम, आपको कैसे भूल सकते हैं. मैं अभी आ रहा था अपने इंस्टीट्यूट पे भी.
So, ma'am, better if you
कैसे
give
मैम
the
अभी?
introduction for Dr. Ajay. You better know him.
सर सत्येन सर.
Yes, sir.
मैं एक प्रिविलेज चाहूंगा कि मैं अपना इंट्रोडक्शन खुद ही दे दूं.
Sure, sir. Welcome.
श्योर
Thank you. Thanks.
So myself.
मैं जिन अजय सर को जानती हूँ उसके बाद अजय सर ने और प्रोग्रेस की है, तो
Yes,
बेटर है
ma'am.
कि वो खुद ही अपने आप को इंट्रोड्यूस करें.
जी मैम बिल्कुल.
Yes, yes, ma'am.
आपकी
नाइस टू सी यू अजय सर.
मी टू मैम. आपको भी देख के मुझे बहुत अच्छा लग रहा है. एक अति जैन करके भी मैंने नाम देखा. एंड एज फार एज आई रिमेम्बर आई टॉट हर इन सम इंस्टीट्यूट. So maybe whether she is there or not, in the participant list I saw that name.
Yes,
Yeah.
sir. Maybe she will rejoin the
Okay,
session.
that's fine.
Yeah.
That's fine.
Actually, Ati madam belongs to Institute of Advanced Computing in Sage University, Indore. So let's see when she rejoin.
Okay,
So
so
I request you just give your introduction and then come to
definitely.
your session.
First of all, तो सत्येन सर मुझे आपसे थोड़ी सी शिकायत है that you are
Yeah,
calling me sir.
Sir,
Let me
you
tell
are
you,
our
everybody.
guest for today.
Let me tell you, everybody, that Satyen and myself was is a friend of more than 30 years tenor.
Yeah, correct, correct. From schooling to engineering.
Everything,
Yeah.
everything basically, and still we are going
Yeah.
on. And
Yeah.
Suman madam is my just like my guru. So she was there in
Me
SGS
too.
ITS Indore when I was working there from 2006 to 2010. And it's thank you, ma'am, giving me your darshan at this time, at this moment of time. Actually, I really respect you a lot.
Yeah, definitely.
I know it. I know it.
Okay. Thank you, thank you. So let me start with my brief introduction. Myself, Dr. Ajay Verma, and I have completed my PhD from DIVV Indore, and my MTech from SGS ITS Indore. So the time when I was doing my MTech, ma'am was teaching there, and she taught me also. After that, in 2010, I joined MNIT Bhopal, and right now I am working there. I have almost 24 years of teaching experience because I started in 2001 with GSITs itself. I was a visiting faculty there. And then I joined some private institutions where probably Atijan was there, that in Rishiraj Institute of Technology. So for five
Right.
years I was there. Then I joined GSITs, then MANIT, and that's all. This is my brief introduction. So, Satyan, should I start the
Yeah, yeah.
presentation
Yes, sir.
directly?
Before that, I need to make you co-host so that you can share your
Yeah, yeah,
PPT.
please, please.
And now it's over to you, sir. You can share the PPT and start the session.
Okay. May I just turn off the camera? Actually, I feel I
Okay,
don't
okay,
feel
no,
better with cameras and all those. So
no
I'm
issues.
just turning off the camera and presenting my PPT here. Just wait, sir. So is the PPT that
Sir,
screen is
your
visible to
screen,
everyone?
your desktop has already. Yeah, yeah. No, PPT. Yes, yeah, it is there, sir.
Visible now?
Yeah, yes. So,
Oh, just a minute, sir. मैं थोड़ा इसको छोटा कर देता हूँ. हाँ. So is it visible?
yeah, yes, sir.
So why I told you that I should start the presentation right now, because I don't want to let the people bore, because my
Yeah.
PPT is already very much bored.
Oh
Okay,
no,
so
sir.
let me start with the topic, the challenges and complexities in the EV supply chains. Very relevant topic. Many of the presenters yesterday, the day before yesterday, and today itself, Farooq sir has already explored, or rather, I should say, explain few things which are there in my PPT also, and he has told everyone in a very manner which is practical. Basically, he talked about some dirty secrets uh, uh, of that particular EV supply chain also. So I will also talk about that. I will try to expand it in a better, in a manner which I have gone through some sort of networks and all those. So I have gone through very much information. But before going, or before starting my presentation, I would like to give one disclaimer that most of the data I have taken from the internet, including ChatGPT, DeepSeek, then Google Gemini is there. Apart from that, no doubt the google.com is always available for us. So, and some other internet materials too. And based on that, I have prepared this PPT. So it may be possible that the data is different than what is available in different platforms. So there may be a difference. So please verify the data before using them. And also, I would like to say that it is just for the information purposes, and not to use as the research or something, some report writing or so. So they cannot be used directly as the final data. It should be verified first and then to be used. So this is the agenda of my presentation. I'll start with the background, then introduction to supply chain, challenges and complexities, then global, we will talk about some sort of global EV supply chain scenario. Then China, we cannot ignore it as far as EV supply chain or EV manufacturing is concerned. And then the Indian EV supply chain. It may be possible sometimes people will feel that I'm a little bit delaying in reading the screen. Let me tell you, I have been dilated in the morning today for some sort of checkup in my eyes. So I am not seeing the screen clearly. So I have to make much more efforts to read the things. So please excuse me if I take some time lags.
No, no, sir, it's not a problem. If
Okay.
after
And
that you are ready to present, sir, we are
no,
highly obliged.
actually,
Thank you so much.
I was having some appointment today, so I could not ignore that.
No, no, sir.
And
Thank you, sir.
I was
Thank you
not knowing
for.
that it will be lasting 8 to 10 hours or so. So
Oh
that
my God.
was basically. That's okay.
Yes, sir.
I'll try to read out clearly. So, as far as the background of electric vehicle is concerned, we can say that the electric vehicles are no doubt this industry is growing rapidly in the last 1 decade, where the leading was taken by China. In 2009-10, they started huge investment in electric vehicles, and as far as battery manufacturing is concerned, it is also being taken care by their government initiatives were there, huge investment were there. So not only because of China, but also American companies like Tesla and others, they also taken the lead, and the electric vehicle market was growing almost about 60% since 2019 to 2023. But it was only 1% or so. I must say that it's a drastic jump. But why this growth or exponential growth is there? Basically, there are some, we can say that 2 or 3 reasons may be there. One, the most important reason is the saving the environment, so that carbon emissions should be reduced. And as far as some reports are saying that all the countries have already gone through zero emission plan by 2050 to 2070. And looking to that, every country has to fall into the electric vehicle market. The second reason is the very obvious reason, which we have already gone through in our schoolings, that the other fuels like that petrol, diesel, coal, etc., they are going to exhaust by almost before the century will be completed. So we have to go for some sort of other type of fuels so that it can be the environment may be saved. At the same time, the fuel will be depleted, so we have to have some sort of alternative fuel so that we can drive the vehicles. Apart from that, we have to transition from sustainable towards the sustainable transportation. When we talk about the trends as far as worldwide trend related to the EV supply chain is concerned, China is leading as far as vehicle EV manufacturing is concerned. We'll talk about them later on, because we are having some data which is showing that China is clearly leading the market. Then followed by Europe's and European country, and then US. But the US market is still not growing up to that pace as the China and Europe. Though many people feel that Tesla is doing a very good job, no doubt they are doing. But the Chinese companies like BYD, they are much more ahead than the Tesla. As far as India is concerned, we can say that after the emergence of what we call that godfather of India, that is the Indian government, their initiatives, their regulations, the Indian market is also growing by in 2024, a drastic growth of 27% has been achieved, which was not so far in the previous years. But when we come to the EV supply chains, they are not so simple as compared to the IC engines. They are very much complex ones. Significant complexities are involved in that supply chains. And what are those complexities? We will be talking about them in this presentation. And the highlighted complexities and challenges, they are the specialized components such as lithium ion batteries, which are the major component of any electric vehicle. Apart from the rare earth materials are involved in that. Again, the second complexity and challenge for the organizations or companies who are making EVs. And then we are having advanced semiconductor chips which are required. You might have remembered that at the time of COVID, the semiconductor chips were not coming to India, and the automobile market was heavily going into the losses that time. So let us start with the introduction. Yeah. So the EV supply chain can be consist of 3 to 4 stages basically. One is the raw material extraction. Second one is the battery production. Then vehicle assembly, logistics and distribution. These are 4 to 5 stages, basic stages we can call, which are involved there. And when and battery production, most of the countries all over the world are struggling with fulfillment of these 2 stages basically. Why? We'll talk about that later on. So this is a simple diagram for the EV supply chain. Initially, or we can say that there are 4 to 5 stages. So one is the raw material extraction. What are the raw materials involved in EV supply chain? Basic raw materials are lithium, cobalt, nickel. Some other materials are not spelled out here, like manganese is also there. Then we are having component manufacturing. The components which are generally used are the logistics and distribution is always there. So for that, we have to go for some sort of transportation and logistic activities. Apart from this, risk management is always there. So this is basically a simple supply chain, EV supply chain. Why we need this EV supply chain, robust EV supply chain? There are few reasons for that. I have already gone through 3 main reasons. The depletion of the basic fuels, they are going on exhausting very fast. Upon that, carbon emissions we need to reduce, though there is a matter of debate sometimes that whether carbon emissions are reducing or not, as Farooq sir also highlighted that one. So what is why it is needed? Because we want stable production and delivery of the electric vehicles. So when we are having a robust supply chain, EV supply chain, then we can produce electric vehicles in a constant manner, and they can be delivered as and when required by the customers. Cost efficiency we want, at the same time affordability. One of the most important reasons because of which people are not purchasing electric vehicle, the affordability aspect. The EV supply chains are generally costlier than the petrol or diesel cars or vehicles. That is why the initial cost basically higher than the much higher than the gasoline engines, IC engine vehicles. So it is a very much important aspect. So efficiency must be increased. At the same time, affordability must be increased so that customer will purchase the electric vehicle. Sustainability aspect is always there, and ethical sourcing is also. When we talk about ethical sourcing, because the mining of these raw materials like lithium, cobalt, nickel, they are very their situations are, or the environment where they are being mined, it is very hazardous to the health. And in some countries like that DRC, that is the Democratic Republics of Congo, where the most of the cobalt mines are there. Most of the time people are working with their hands and extracting the cobalt, and that's why many times the human resource peoples are embarking on the unethical activities going on in the minings, and they are time to time they are raising their voices for those people. Apart from that, child labor is also there in those minings. So these type of things we need to take care, and therefore if the robust supply chain would be there, then maybe the unethical sourcing of the raw material will be reduced. Then reduce dependency on the volatile markets. If your supply chain, EV supply chain is robust, then definitely the market fluctuations will not affect a lot on the supply of the electric vehicles. Now, basically, when we are talking about the supply chain, we talked about the raw material extractions and some other components which are used in electric vehicle. Why I have taken this? Because yes.
No, no, nothing, sir. Sorry for the inconvenience.
No, that's okay. So, what are the key materials which are used in electric vehicles? So basically, the most important component of the electric vehicle is the battery, which is being composed of these materials, which are the main component. So when we talk about a battery of electric vehicle, the anode and cathode are there, and the separators and the solvent is there. When we talk about the anode is generally made up of graphite, while the cathode, the most important component, it is being made up of lithium, cobalt, nickel, and manganese, where these two elements, lithium and cobalt, they are the most important component of the battery, because they are the uh, costliest, as well as the lithium ion batteries cannot work without lithium. This is the most important. Then cobalt, which is increasing the capacity of the battery and its longevity. At the same time, capacity of increasing the wattages per weight, basically means per kg how much the battery will be providing you the wattage. This capacity is being increased by the cobalt. At the same time, lithium itself has that capacity. That is why it is mostly used because of these magical properties, like as compared to the batteries which we are acid batteries we are using, they may carry on almost 5 to 8 times of the wattages for the same weight. That is why these two components are very much important. Then rare earth elements are used. We already given some names of their terbium and all those. So they are used in the electric vehicles, which are also again rare, so costlier. Semiconductor are used for the electronic systems, and then aluminum and steel for the chassis. Now, after going through this brief introduction of EV supply chain, let us talk about some of the giants as far as electric vehicle is concerned. I have not included here any Indian company because they have been taken in India's supply chain, EV supply chain, and their share is also very low as compared to these companies. So the leading EV manufacturers are Tesla, very well known, BYD from China, Volkswagen and Neo. This Neo company, you might have seen there in the Indore Bhopal buses. You might have seen those buses by the Neo company. So, and apart from that, battery manufacturer CATL is the largest manufacturer of lithium-ion battery situated in China. LG Energy Solutions is also there, and Panasonic from Japan. Then raw material suppliers are there. These two suppliers generally providing you raw materials, taking them from the mines and the reserve where they are present. So, how globally the EV supply chain is going on? Growing demand for EV driven by sustainability goals. At one hand, the demand of the EV is going on increasing. At the same time, the sustainability goals have to be achieved. That is why the globe is basically running behind the electric vehicles. Then government incentives and regulations, they are forcing companies as well as customers towards the electric vehicles. There are most of the time in majority of the countries, including India, we are getting lot of incentives when we are purchasing or making the electric vehicles, such as the GST on electric vehicle is only 5%, while GST on the other IC engine vehicles is 30 to 48%. So this type of incentive to the manufacturers and customers, they are getting subsidies on electric vehicle purchase. So these type of initiatives are definitely working a lot. Then increasing investment in battery production and semiconductor production. These two, which are the most important aspect of battery, electric vehicle battery, they are being taken care. So globally, all these activities are going on, and that is why EV market is growing very fast. This is a glimpse of market share of the electric vehicle. You can see the China is 40 to 45%. Maybe this data is for 2023, because recently I have gone through some report that China has covered almost 60% of the electric market all over the world. The European countries, they are having 20 to 25% of the share, while United States 10 to 15%. It is nearly 10 to 12% basically, and rest of the world 5%, 20%. Where India stands here, because India has nearly 2% of the world's market share as far as electric vehicle is concerned, 1 to 2% basically. Now, what are the challenges of electric vehicle? We are coming to the basic topic of our today's presentation. So when we are talking about the challenges, I have divided those challenges in some sort of from the battery component point of view, EV supply chain point of view, customers and government point of view, and so on. So as soon as and when the topic title will be there, from that point of view, we are getting the challenges. So first challenge is from the raw material side, or raw material sourcing. So as I told you that China is dominating as far as this EV market is concerned. 60% of the whole world's market is captured by China. And but why? Or rather, I should say how? They have captured on the basis of these limited availability of lithium, cobalt, and nickel. The world's lithium, cobalt, and nickel contents or mines. In the next slide, probably, yes, this is. You can see the lithium reserves all over the world in a better manner in this table. Basically, 4 countries, Chile, Australia, Argentina, and China. Basically, these 4 countries are having most of the reserves of the lithium. Even in them, Chile and Australia having the highest percentage of lithium reserves all over the world. But how could China become the could have the 60% market? Because in 2012 or 13, China invested heavily in these countries as far as lithium mines are concerned. Australia, which is having almost 23% of the lithium reserves, 24% of the lithium reserve, they are not having any processing unit for the lithium. So basically, what we can say that it doesn't mean that Australia is the or the Chile are the richest as far as EV market is concerned, because lithium cannot be sold directly. It has to be processed, then sold, and again it may be the processes which are recycling them. Again, they are being sold, and so on. And Australia doesn't or Chile doesn't have such a capacity to process that lithium. So most of the lithium has been taken care by China itself. Almost 50 to 60% of the lithium from Chile and Australia, they are being importing, processing them, and making the battery, lithium ion batteries, or they are selling that lithium to other countries. That's why China is much ahead than other countries. So this is the lithium reservoirs. So limited availability of the raw material, that is lithium, cobalt, nickel, manganese, etc. Very recently, I have heard some news that India has also found some sort of lithium mines in Jammu and Kashmir. But they are basically potential mines, maybe there. They are not proven mines. So let us wait for that, so that it will be there. And if it will be possible that they can be processed, that will be a very huge benefit to the India. Because right now we are 100% of our lithium ion batteries are being, almost 100% are being imported from other countries. Even them, and even then 70% from the that 100% is from China. Then second one is supply concentration of yes. So all these raw materials are basically concentrated in some of the few countries. Just like DRC, I talked about, Democratic Republic of Congo, they are having almost 70% of the cobalt reserves. Again, China has invested heavily there in most of the mines there. So if we can say that if 20 mines are producing some sort of cobalt, almost 13 to 14 out of them are governed by China government. Then environmental and ethical aspects, we already talked about that. Yeah, this is the world's cobalt reservoirs or reserves. So you can see that DRC having almost 50% of the world's reservoir, and that is being generally selling the other countries because they don't have the processing units and all those. And even then, most of the time they are exporting to China. Then there are some sort of challenges from the point of view of supply chain, battery supply chain bottlenecks. So battery production dependent on critical minerals. You can see lithium ion, lithium and cobalt, they are the critical elements concentrated at some portion of the world, some areas of the world. So the battery production is dependent on them, which is one of the challenges to all other countries in the world. These challenges are basically common for the most of the countries in the world. High demand versus limited supply, causing price volatility. Again, one of the challenges, because the demand is high and the supply is limited, because of these constraints, and many times some sort of geopolitical situations are increasing, such as the Russia-Ukraine war, or so the something like trade war between US and China. So that time also the supply is disrupted. Because of that, the challenges are emerging. Dependence on China, one of the challenges for the world. Then ethical concerns are there. Ethical and environmental concerns are there. Child labor, and as I told you, that labor have to work with their hands in some of the mines. So it's also not good. Then at the same time, as far as environment is concerned, uh, one of the what we can the dark side of this EV is that lithium extraction is highly water consuming activity. So it is believed that in Bolivia, where there are reserves of lithium, because of this mining activities or extraction activities there is a huge shortage of water, because it is consuming a very huge amount of water while extracting. Actually, I am not having the technical details of that, how much it is consuming, but it is consuming a huge amount. So that is one of the concern as far as environment is concerned, is related. Then pollution and ecosystem concerns or challenges because of these mining activities and extraction activities going on. Geopolitical issues, US-China trade war, one of the reasons. Many times export restrictions are there, and because of that, many times the materials are not coming to the countries uh, as per the situation. Many times the countries are imposing export restrictions. Again, dependence on China, ये बार बार आता रहेगा. Okay, then there are complexities in semiconductor shortages. You have seen in COVID time, most of the news channels were telling that auto market is encountering a huge shortage of semiconductor chips. And that time, the vehicle shortage was also, the queues were very long as far as the vehicles are concerned. So global situations, when they are going on changing, it may be the shortages of semiconductors. High demand for advanced chips in the electric vehicle, such as ADAS and infotainment system, which are generally installed right now in the vehicles. So it's an advanced driver assistance system. Because of these demands, the semiconductor chips may again be in the shortages. So there are some challenges for that. Limited manufacturing capacities concentrated in Vietnam, Taiwan, and South Korea. South Korea and Taiwan are the one of the largest manufacturers of these semiconductor devices. High production cost, one of the most important challenges as far as EV is concerned. You can see that if they are not popular in among the people, among the consumers, compared to petrol or diesel vehicles. And one of the reason is high production cost. Because of that, the initial cost is very high, and that's why they don't they are not willing to purchase. Though in long term, when we talk about the total cost of ownership, then definitely EVs are not always, but most of the time, they are economical compared to the petrol and diesel vehicles. And there is another concern related to this initial cost or not adopting the vehicles, that if government imposes some regulations that you have to purchase, as we have seen that Indian government is trying to replace the diesel vehicles by 2028 to 2030. So let us see what happens. But they are trying to replace them with the EV. And how it will be done, that's a matter of future. Supply chain disruptions may affect a lot to the manufacturing also, because when supply chain is disrupting, definitely lithium which we are importing from other countries, or some other components, they are not reaching to the companies, not only India but all over the world, and therefore they are having those challenges. Economy of scale could not be achieved because the demand is less, and companies are not investing a lot. Now they are starting investing, but in the last 5 years you can see that only Tata Motors was there in India who was manufacturing the electric vehicles, apart from some Reva company which initially started their vehicle but could not be succeeded. Then Tata Nexon, one of the most successful vehicle that time, and now it is Mahindra and Mahindra and other companies. As far as car market is concerned, they have also jumped into the EV market. Two-wheeler market is already growing. At this point of time, let me tell you that our Indian EV market is basically growing with the help of three-wheelers and two-wheelers rather than cars or four-wheelers. Battery recycling and disposal. As Farooq sir was also telling about this, the recycling of battery is very difficult as far as EV is concerned. Why it is difficult? Because the components which are there and even the raw materials can be recycled. But as far as some reports are saying, the processing is very costly, that a new battery can be manufactured rather than recycling it. So people are dumping those batteries in lands and even in the sea, and then definitely they are making the environment pollution. Limited infrastructure for battery reuse and the second life application basically is related to recycle, because it is a very difficult, very costly item. So most of the companies are not doing it, but now they are focusing on that. Logistics and transportation of batteries. The transportation of battery requires a special type of vehicles and their safety, and because they are very much hazardous to heat and other things, so that need to be focused on. I think this we have already gone through. Yeah, government regulations and trade policies. This is important. For the last 5 to 8 years, our Indian government is also doing very good as far as EV promotions are concerned. The tariffs, as far as if other countries are considered, then they are imposing tariffs on the EV components and all. So that's one of the challenge, because component prices are going on, and other countries, the countries who are manufacturing them, they are enjoying all the reduced prices of the manufacturing of the EV vehicles, but other countries are facing a difficulty in that. Carbon emission regulations are impacting the manufacturing of the EV, because these regulations are also to be met. They have to be imposed on the company so that emission can be. Yeah, sometime Farooq sir was saying dirty secrets of the EV. So I recalled at this point of time that production of electric vehicle is emitting almost more than twice the carbon emissions compared to the petrol or diesel vehicles. So at the time when we are producing them, that time the carbon emissions are much more than what they are on the these petrol diesel vehicles, ICE engine vehicles. So when we talk about reduction of the carbon emissions, we should consider this challenge also. We should not that the company should not make so much of carbon emissions. At the same time, when we are running the electric vehicles, they are working on the with the charging of electricity. So electricity generation in most of the time in our India is because from the coal and other power plants. So we need to cater the scope of getting power or electricity from solar or unconventional sources of energy, so that we can say that really it is environment friendly or reducing the carbon footprints. Incentives from the government is definitely boosting electric vehicle market. The PLI schemes and US schemes they are also as far as India is concerned. PLI, FAM1, FAM2, these are the schemes where they are giving incentives to the manufacturers, subsidy to the customers. Impact of COVID-19. That time, if you see, these type of situation may occur anytime. Some sort of say war or COVID-19 or some other type of turbulent situation all over the world. That time you can see that factories are shutting down. We are facing with the labor problems and so on. Yes. Then technological barriers in EV manufacturing. So advancement of solid state batteries is in the nascent stage. It is not, we can say that fully developed, so that lithium ion batteries can be improvised. Solid state batteries, LFP batteries, they are called, as far as I remember, and they are using other materials compared to as compared to lithium and cobalt and all those. Some sort of component may be manufactured with that. Then we require high-tech production manufacturing processes. R&D should be done properly, and the investment should be put in the R&D, so that the technological barriers can be overcome. Consumer demand and market uncertainties. As I told you that high cost of the purchase of that particular vehicle, this is one of the reasons that people are hesitating to purchase electric vehicle. So that need to be taken care. Charging infrastructure, it is one of the challenges, but as far as India is concerned, some companies like Tata Power, they are doing a wonderful job in installing the charging points. Companies now, they are giving a sort of guarantee that wherever their charging points are there on highways or so, they can charge without paying any money. So that type of activity should be there. Prices are rising because of the shortage of the components as well as lithium-ion batteries. Then cybersecurity risks in the softwares. So because electric vehicles are running on with the help of softwares, so they need to be means better secure compared to the previous ones. So we have already talked about many things of the China electric vehicle supply chain, but there are few things which are differentiating China from other countries. Like the government of China has taken initiatives way back in 2008, 10, 8, 9, and other countries are starting after 2014, 15 or so. So because they have started so early, they are having early mover advantage. That is why they are number one right now. So government policies in China and subsidies were heavily given that time. Heavy investment in the battery technology, as I told you that from purchasing of mines in the lithium reserves and cobalt reserves to installing huge processing units in China. These two activities made them fully owned batteries in their home, and that is why they need not to import. They are mostly exporting many times. And control over raw material, as I told you, most of the mines, most of the processing units, they are being owned by China, and that is why it is dominance. 60% of the market they have captured. As far as EV market all over the world is concerned, 80% of lithium refining capacity China is having, which making it number one. Because then leading EV companies of China are BYD, NIO, Expand, and all those. These are the key players of China as far as vehicle manufacturing is concerned. BYD, battery manufacturing is concerned, CATL, it is the largest company. Then NIO and Xpeng are emerging as the new giants. So we already talked about that. China's lithium and battery production strategies controls most of the majority of the lithium refineries because they have invested heavily there. CATL is the largest battery manufacturer in the world, and BYD has become in 2024 the largest EV seller um, by beating the Tesla. So government support to the Chinese companies is always there. But there are few challenges also. Trade war between China and US, they are affecting their uh, exports, and because of that they could not export to America. Competition with US companies and European companies like Tesla and others. So here are some takeaways from China's dominance in the world market. The number one point is the early government interventions or investment in the electric vehicle market. The most important thing, heavy investment, focus on battery recycling and sustainability. So here is the thinking philosophy of different countries compared to China. The US market is relying on domestic battery manufacturing and production because US is also having some of the mines of lithium and cobalt. So they are using them, or they are purchasing from the countries where the China's intervention is least. European country focuses on sustainability and green battery technology, while China, why they have grown because strong government backing, and at the same time their supply chain is controlled by them own. Now, as far as India is concerned, The India has already, as we talked about that, it has already gone up to 2 million vehicles in the 2024 with a rise of 27% jump in the sales compared to the previous year. This is a basic supply chain for Indian EV manufacturers, which is almost similar to that one where we are having raw material extraction. Generally, we are importing that raw material. So we can say that starting with the import of the raw material, then battery manufacturing. Some of the companies in India like Ather Energy and some other companies, they are trying to make those batteries, better quality batteries compared to the China in India itself. Ather Energy is working very hard for that. Then we are having EV manufacturing where we are generally going with the assembly of the vehicle by integrating the battery and other components, logistics and transportation of those batteries to the customer, and then after sale services and others. So Indian EV vehicle is also growing rapidly in the last 3-4 years. EV sales are also growing. Key players in the Indian market are Tata Motors, Mahindra Mahindra. I have given the list of those key players in the next slides also. Yeah, here it is. So when we talk about, as far as India is concerned, the manufacturers who are making the cars, two-wheelers, etc., these are the manufacturers. Tata Motors is there. Mahindra and Electric has also entered into this by launching two cars in the market. Ola Electric in two-wheeler market, they have already launched their 3 to 4 vehicles. Ather Energy really working hard with their model 450X. Apart from that, Hero Electric has also launched. Then Bajaj Auto is there, TVS, and many more. As far as battery manufacturing is concerned, there are companies like Amara Raja Battery, Exide Industry, Ola Electric, and Log9 Materials. And when we talk about the component battery recycling, then we are having Gravita India, Etaro, and Epsilon. So most of the time India is importing the batteries from the other countries, and most of the import is from China, which is almost 70% of the total battery import, battery and even the components basically. So domestic production is still in its early stages. As you see that the reason is generally basically the non-interest of the people, customers, as far as EV is concerned. So they could not scale up their production basic. This is one of the most important reason. Logistics and infrastructure challenges are also there. India's logistics network is underdeveloped for EV supply chains. As I told you, that specialized vehicles and specialized transportation is required for that. So for the as far as the EV vehicles is concerned, that need to be improved. This is one of the challenge. The EV components requiring specialized handling as well as transportation. Charging infrastructure is a bigger challenge which need to be focused on, so that the people should not be having that an anxiety of not reaching to the destination when they are running the EVs. Then economic and cost challenges. The cost should be reduced. It is the initial cost should be reduced. Basically, the high initial cost is stopping people to purchase electric vehicles. Battery cost, which is contributing to almost 40% of the electric vehicle, they need to this also to be dropped down, and this only can be done when we are having our own battery manufacturing facilities at large scale. Limited economies of scale, this needs to be improved, and as and when the people will get purchasing the EVs, definitely it will be improving. Recycling and circular economy, I think Farooq sir has already in detail, he has already gone through the circular economy points, so I need not to say anything here. Then future perspectives there, opportunities are lying as far as Indian market is concerned, because we are the largest country as far as population is concerned, and we are having very less EV vehicles on the roads. So opportunities are huge here as far as component manufacturing is concerned. At the same time, other that the battery manufacturing is concerned for the companies, for the organizations. And the newer technologies are also coming, like battery swapping technology, so that we don't have to wait for the charging of the battery, but you can just take another battery from the swapping stations and go without any hassles. Government is pushing, rather I should say pushing a lot, and it need to be pushed much more than that. So this needs to be done. Yeah, one more point, private partnership is also required. More and more private industries and partners should be there. So definitely, as I told you in the initial slides, that India trying to replace all the diesel vehicles by 2028, but even petrol vehicles by 2033 or so. So it can be achieved with all these activities which we have mentioned earlier, and government support policies, incentives and subsidies. Solid state batteries, we talked about it somewhere, that they are in the early stages. They should be, as soon as possible, they should be implemented. AI driven supply chain should be there, which can increase uh, the optimization of the batteries. And localization is also required as far as component manufacturing is concerned. As far as battery manufacturing is concerned, localization means the batteries and components should be manufactured in India itself, rather than importing from the other countries. So in conclusion, rather reading it, I can say that this electric vehicle market is growing rapidly. It can be catered. The India can be the leader if they are focusing on their own strengths. They try to reduce the imports from other countries. If this mine from Jammu Kashmir will work, definitely India will be the one among the race of peoples who are running very fast. At the same time, investment and government support should be there, so that electric vehicle market can boom. So that's all from my side. Thank you very much. Such suggestions are welcome from your side.
Yeah, thank you, Ajay sir.
हाँ, थैंक यू सत्यन सर. फिर सर बोला आपने, मैंने भी बोला.
So, sir, there is a question
Yeah.
from Mr. Rajesh. Rajesh sir, please unmute yourself.
Hello, yes, sir.
Yeah,
Sir,
Ah,
please.
yes.
yes, sir. Wonderful session, first of all.
Thank
And
you.
Sir, I have a question I posted in the chat also. Sir, I want to know your views regarding challenges in sourcing raw material like
Mhm.
lithium or cobalt for EV batteries. What are the biggest challenges in your view, sir?
Yeah, the biggest challenge is that, sir, in my opinion, basically, and as far as whatever I have gone through in the last 1 or 2 weeks, that these raw material, lithium, cobalt, nickel, they are basically, these mines or reserves are not in India. This is one of the biggest challenge, and that is why we are dependent on other countries like Bolivia, China, Chile, Australia, and all. And most of the countries are sending the material to the China, not 100%, but most of the time. So because they have already intervened in this importing and other things in 2013 itself, we started a little bit late, but it doesn't mean that we cannot challenge them. So the challenge is that we don't have these materials which are not now something is not available in our country. So it will be a difficult task for any country to compete. But as I told you, the fortunate part is that uh, recently some sort of lithium reserves are being detected in Jammu and Kashmir. So we are hoping that, at least I am hoping that those mines are proven mines, so that India will also be in the competition.
Yes, sir, definitely, sir. I think, sir, you are true.
Actually, we are
That
having.
Yes, sir.
Let me add some more things, sir. We are having all the component manufacturing units, all other parts we are making as good as China is making. We are just lacking in batteries, lithium ion batteries, and their components like lithium, the raw material basically. Otherwise, India is nowhere. India is behind the China.
Yes, sir. Yes, sir. And presently, we are procuring from other countries. I think the cost is too much right now.
Definitely.
And yes, sir. And naturally, geopolitical tensions are there along with that. So, sir, can I have another question, please?
Yes, please. Yes.
Sure, sir.
Sir, yes, sir. Sir, my question is that what, according in your view, how government can play a vital role in framing policies or to make international collaborations so that this EV supply chain can be made available for the manufacturers?
Yeah, definitely. Uh, what I say that, because we can't do anything as far as raw material is concerned, but the other processes like because we are having a huge infrastructure as far as car body is concerned, chassis and all those components and other components which are not related to the battery part. These companies are having very large amount of experience, very large experience as well as the facilities also. Government should provide more incentives, more subsidies to those companies so that they are means willingly they will be there. More companies should come forward for making electric vehicles. As far as supply chain is concerned, the bottlenecks which are due to the say tariffs or these type of things, they should be removed from government side, and they are trying hard for that. They have to sometimes they have to impose tariffs because to stop more imports from the China, they need to increase the tariff so that Indian or local manufacturers get some benefit. Secondly, as far as component manufacturing is concerned, the OEMs, original equipment manufacturing companies, they have to be increased at the local level so that most of the parts, even the parts which are being imported, such like semiconductor and all those, the newer technology can be implemented, and those semiconductors can be manufactured here also, because we are lacking in lithium and cobalt, but we are not lacking in the some sort of minerals or elements which are required for semiconductors. Though we are having a little amount, but they are available, but their processing is difficult. The plants for processing and recycling of the materials is not there. Third thing, if we can improve our recycling capacity of lithium cobalt, because as I told you, these are recyclable materials, but their recycling is difficult. So government may initiate some sort of say innovations and promotions of the activities which are promoting those recycle. And if some newer technology comes where the production that recycling is getting easier and less costlier, then definitely we'll be having upper edge.
Wonderful, sir. Wonderful. Thank you.
Thank you, sir.
And you are, sir, totally right that second life of the battery is very useful, and naturally it will reduce the overall cost of the system. And
Yes.
naturally, and sir, I think this is a very good point that which you mentioned, that subsidies and government financial facilities naturally will boost this market.
Definitely, it
Uh,
is not a long-term solution, but for initial stages, as we are in the early stage of this EV market race, so we have to give these things. It's not a long-term solution because in long term, the government has to withdraw the subsidies. Definitely,
yes, yes, sir.
when we are on our own toes, then that time
Yes,
we can
right.
withdraw.
And sir, I think in my view, China is naturally it is heading whatever means in every field, and it is making challenge for these developing countries to compete with the pace
This
through
is
which they
really
are
difficult.
actually going.
It's really
Yes,
difficult to compete with them because their infrastructure they have already grown. Their people, most of the that people are working there basically
yes,
and
sir, yes, sir.
working in a manner which is something like they are going for a war and doing
Yes, sir,
everything.
yes, sir. Yes, sir, yes. Thank you, sir. Thank you for the
Very
insights,
true.
sir.
Thank
Thank you, sir.
you.
Thank you.
So, any other question from the participants? If you have, I don't find any question in my chat box.
Hello.
Yeah,
Hello.
sir, Santosh,
Yeah,
sir.
Santosh ji, boli.
Good evening, sir.
Good evening.
Sir, as the topic we are discussing on the challenges and complexities in the electrical vehicle.
Hmm.
Sir, just I want to know that there is only one challenges in the electrical vehicle regarding the battery, because whenever I
It is
thought
the biggest
that
challenge basically.
it is the biggest challenge. Sir, there is another, actually I have got a project and
Hmm.
there is another challenges I have to face,
Yeah,
that
yeah, please.
other than
Let me tell you, I would like to tell the audience basically that I am not expert of this EV and all those, but
okay.
something happened like that. I have to give presentation on that, uh, and I tried my level best, whatever I can. But yes, please, you share your whatever you have with you, that challenges and all those, because you are doing some projects, so definitely you are having more knowledge.
No, no, sir, not more knowledge.
No,
Actually,
please share. I
I am
also
making
want to know.
the MTech students. I have got for that. And recently, it is not a very R&D topic, but whenever I design a particular vehicle, okay, for him, then there is a design aspect. I think it gives very much importance for that design aspects. So,
Definitely.
and since I can't tell you because it is my patent project. Yes.
Okay.
क्या you just tell जो 120 participants है कोई तो छापेगा.
सो हाँ, मतलब मैं इसको खुल के थोड़ा सा नहीं बोल पा रहा हूँ
नहीं, मत
एक्चुअली.
बताइए आप अपना जो एक जिस्ट अगर आप बताना चाहें तो वो थोड़ा सा जरूर शेयर करें.
जी, तो वही मैं बता रहा था कि सर जो डिजाइन एस्पेक्ट्स है इसका, जो उसका एस्थेटिक है या फिर हम बात करें उसको, क्योंकि अगर मैं सोलर पावर की बात कर रहा हूँ, पर्टिकुलर हम ई व्हीकल की बात करते हैं ना सर, तो
हम्म,
यहाँ पर मुझे क्या लगता है कि हमको सोलर पावर के ऊपर ज्यादा बात करना पड़ती है, क्योंकि अगर मैं दूसरा रिन्यूएबल एनर्जी सोर्सेज की बात करूँ, इट इज नॉट फिजिबल. या मैं विंड एनर्जी की बात करूँ या फिर अगर दूसरे टाइडल वगैरह, पॉसिबल है ही नहीं. तो फिजिबिलिटी तो मुझे सोलर में दिख रही है और सोलर के ऊपर मैं काम कर रहा था. तो वहां पर सबसे ज्यादा इंपॉर्टेंस जो मुझे लगा वो था डिजाइन का, कि आप किस तरीके से व्हीकल को डिजाइन कर रहे हैं. क्योंकि अभी हम अगर पढ़ भी रहे कार के ऊपर वो लगा दिया था, उसकी छत के ऊपर एक सोलर पैनल लगा
लगा
दिया,
दिए थे, यस।
तो वो इतना नहीं है मतलब। लेकिन मुझे ऐसा लग, जो मैं अभी डिजाइन में कर रहा हूँ, मुझे ऐसा लग रहा है कि वो मतलब वो बेस्ट सुटेड होगा, मुझे ऐसा लग रहा है। मैं अभी वो जब उसको मार्केट में लेके आऊंगा, तब मुझे कमेंट्स मिलेंगे बहुत सारे, और फिर मैं आपसे डिस्कशन करूंगा इस विषय में।
That's wonderful. Actually, what I am saying, people has to work on this area basically, because when if we are generating electricity by emitting lot of carbon and then saying that we are reducing the carbon emission, it's not
Yes,
viable. Basically, we should go for some sort of unconventional source of energy
yes,
which can generate electricity for the EVs. Then it will be a beneficial thing.
yes sir, yes, थैंक यू सर।
No,
मतलब वही
and I tell you, as far as you are talking about design, na, the electric vehicle basically require lightweight.
यस,
So that is why we are using lithium and lithium ion batteries, because they are very much lighter and their efficiency capacity is almost 95% compared to the petrol and diesel, and almost 4 to 5 times of the capacity per kilowatt per kg.
यस,
So that is why it is basically requirement of the society, requirement of the electric vehicles, that you design that particular item, or
यस सर,
somebody will design so that solar energy can be utilized in EVs.
बाइक पे भी बाइक
Hello.
ओके, थैंक यू सर।
Okay.
Sir, such discussions are fruitful for all the participants.
For me also. Definitely.
Sir, you wanted to be a learner always.
I am always. तो सबसे ज्यादा फ्रेंकली स्पीकिंग मैंने सबसे ज्यादा तो सत्येंद्र से ही सीखा है।
अरे no,
Tell
sir.
you.
No, no.
क्योंकि 30 साल से मैं सत्येंद्र को देख रहा हूँ,
Oh my God.
ऐसा इंसान नहीं है, मैं कह रहा हूँ।
बिल्कुल सही बात है सर, बिल्कुल सही बात
So, any other participant, if want to join this discussion, you are welcome, please. A few participants have wanted to say you thank you for the nice
Uh,
presentation.
Oh,
Stender
thanks to
sir,
all
I
of
want
them.
to add something.
Yeah, yes.
Yes,
Uh,
sir. Sir, I think charging infrastructure to meet those challenges as well as those to achieve those facilities. I think faster deployment is one of the target where
yes,
manufacturing units are focusing. And next part, if we see the papers, then smart grid integration. Integration is the facility on which the units are working. And naturally, as I said, renewable energy, how we can use what means we can use in those systems so that we can integrate different energies on those grids. That will be the thing which we will see in the future, and R&D is going on. And naturally, government incentives will play a very important role, sir. How
definitely.
government is taking this field so that our next generations can use these facilities in the time to come. I think that part will be the thing which will play its role.
Definitely. So basically, three challenges have to be focused on with all our powers, all our energy. One, as you told, charging infrastructure, because why people are not purchasing EVs? The basic two reasons. One,
Yes, sir.
higher initial cost. Second, if they get out of charging of the battery in between the road, mid of the road, then what will they will do? If they want to go to from Bhopal to Indore or Indore to Bhopal, and the battery is not providing you a capacity of 200 kilometer, then they will be stuck there. So this
Naturally.
anxiety of getting exhausted, this is one of the main reasons. In petrol and diesel, no such type of problems are everywhere. Their petrol pumps are there. So when we are providing them charging infrastructure in a proper manner, as I have heard that Tata Power has got an order for installing 10 lakh charging stations all over India within a 3 or 4 years of tenure. So that type of initiative has to be taken. And now on Google Maps or some sort of that internet also, they are providing you information that on this particular highway at what distance the charging station is there, so that you can charge accordingly. So these type of things to be increased definitely, and the initial cost to be reduced. And initial cost is higher only because of the rare earth materials and lithium, cobalt, etc., because mm, they are not available easily. They have to be imported, they have to be extracted, they have to be processed. That processing, extraction, when the technologies will come which will reduce the cost of processing, cost of extraction, then definitely the EVs will also be having initial cost lower than. And as I told you, government is doing a very wonderful job. They are providing 5% GST to EVs and 48% to petrol and diesel. Even then the prices are the difference in the price is very high. So that these two three challenges are the one of the biggest challenges basically. As far as companies
Yes,
are
sir.
concerned or India is concerned, the biggest challenge is to get the raw materials, battery components, these three ones.
Yes, sir. Yes, sir. Totally right, sir. Totally right.
Thank you.
Wow. Any other participant? Sir, I think we can come to the conclusion.
Yes,
uh, so, with your permission, I would request Dr. Amit Bahekar, sir, uh, for a vote of thanks. Amit, sir, it's now over to you.
Yes, sir. Yes.
Yeah,
Yes, sir.
it's
नहीं,
your
जरूरत
turn now.
नहीं है उसकी, आप
नहीं,
सिर्फ
नहीं, नहीं,
आपने कह दिया, मैं बहुत
नहीं,
बड़ी
नहीं.
बात है.
No, sir,
Thank you, Dr. Ajay sir. Thank you
it's
very much.
Indian tradition, sir.
Sir, it was
It
a
is also
wonderful.
one of the challenges. ट्रेडिशन नहीं छोड़ पा रहे हैं लोग.
Yes, sir. अच्छी चीजों को क्यों छोड़े, सर?
Yeah, definitely, definitely.
थैंक्स गिविंग तो सबसे बेस्ट है.
So, Dr. Ajay sir, it was very wonderful presentation and very information regarding EV. You have provided very precisely. Some point I have just highlighted the very good point for the participant also, that you have just explained the EV component and raw material used for the EVs. That also very important for us. Also, challenges in the raw material you have discussed, and participant also noted this, that many ethical and environmental issues like that child labor is the main issue that we are discussing in the main session. This is the bullet point of the session, the ethical and environmental issues. Then advanced in that solid battery, you also very well explained, and market uncertainty. In the whole session, sir, one slide I very much like, and I take a screenshot of that also. Very nice slide, that lesson from China. The slide is very lesson, very good. That things we have to learn from China, so that we can grow the EV like China. So very nice points you have mentioned in that slides, the lesson from China. Other than that, very then other points you very pointedly just explain that cost and logistic and infrastructure challenges, and that is charging station are very less in the India. We are facing the charging station point, less charging station, because of that selling of EV is very low. So that point we are very nicely explained, and thank you very much for sparing a valuable time with this busy schedule. And me and Satya Sharma sir decided to conduct a expert talk physically on our Sage University very soon
No,
for
offline,
our
yes.
students. So be ready,
Yes.
sir. And
Yeah, thank
heartily
you,
thank
Amit.
you very much from
Thank,
the Sage University, Department of Mechanical Engineering and Department of Advanced Computing. Thank you so much, sir.
thank you, Amit, and thank you, Satyendra, and thanks to Suman ma'am and other participants, and
Yes.
everyone who was listening so patiently to me. So I would like to thank all of you And definitely, I will be more than happy if I could present. I can present a session on this topic or some other topic physically at your
Yes,
institute.
yes, sir.
Oh, thank you so much, sir.
Thank you.
And I would thank Rajesh sir also for giving this chance to discuss for more time.
Thank you, sir. My pleasure.
नो सर, आप ही हैं जो थोड़ा सा चीजों को थोड़ा सा पेस देते हैं. थैंक्स अ लॉट सर.
It's our pleasure, sir. It's our pleasure.
सर, ये टू वे कम्युनिकेशन बहुत जरूरी है.
Rajesh sir, thank you from my side also.
Oh, no, sir. No. It's our
And
pleasure.
once again I would like to thank Abdullah sir. उन्होंने भी सेकंड सेशन completely attend किया. फारूक सर, thank you so much sir
सर
for
माय
giving
मोस्ट प्लेजर सर, मोस्ट प्लेजर. सर की
sir.
सेशन में ज्यादा बहुत क्या बोलूं सर, ज्यादा सीखने को मिला. इट अलाउड मी टू गो आउटसाइड द बॉक्स. जिस बॉक्स में मैं था, तो सर के सेशन से वो बॉक्स से बाहर आने का एक अपॉर्चुनिटी मिला. थैंक यू वेरी मच सर. इट वाज अ वंडरफुल
ये आपका बड़प्पन है.
लर्निंग प्लेस.
थैंक्स.
आज के दोनों स्पीकर हमारे रियली एक जैसे ही हैं. दोनों लर्नर हैं, दोनों ने दोनों के सेशन अटेंड किए.
नहीं,
तो मतलब ये
मैंने
भी
कल
सीखने
भी
वाली
किए
बात
थे.
है हम सबके
मैंने कल भी
लिए.
किए थे दोनों सेशन अटेंड.
ओह माय गॉड, थैंक यू सर,
एक्चुअली
थैंक यू.
ड्यू टू एकेडमिक ऑडिट परसों का नहीं कर पाया था मैं अटेंड, पर हमारे यहाँ का ऑडिट चल रहा था. बट
ओके
yesterday I attended both the sessions.
ओके ओके. Sir,
And
tomorrow there will
thanks
be a
a lot.
scientist from RR Cat. You are most welcome.
Yeah, I will definitely be there.
Yeah, yeah. Wow, great, sir.
Okay.
So, thank you all the participants and speakers. Uh, Thank you, Amit sir. Okay, so if you all permit, we can
Yeah,
end this session.
definitely.
Yeah,
Okay, good night to all of you.
sir. Thank you very much, sir. Good night, sir.
थैंक यू सर. बाय बाय. गुड नाइट.
Bye, good
Good night,
night.
sir. Okay, okay. Bye, sir.